morning, everyone. Welcome to the ABFER 8th Annual Conference, the first session on trade growth and development. Okay, I will be the chair of this session. My name is Paul Lee from Singapore Management University. In this session, we will have 3 talks, and 1 hour is allocated for each paper. This includes presentation and open discussion. So when you have questions, you can input or submit your questions to the Q&A or chat function. And when I prompt you to speak up, the control staff will unmute your mic. Okay. And so the speakers will be prepared to take questions throughout the presentation. And in between the 3 talks, we will have 15 minutes break. Okay, I think we can start the first talk given by Jiao from Fudan University.
Knowledge economy. So we know that during the pandemic, we need to do a lot of remote communications with our friends and causes, right? So this paper is going to be about communications cost, but it's not about a pandemic. Okay? So this is our motivation. So firstly, during the past few decades, we have seen a lot of developments in the information and the communications technology. Can you see my screen clearly and hear me clearly? Okay, can you hear me? Yes. So thank you very much for including our paper into the program. Today, I will present a paper joined with Lin Tian from INSEAD. The title of the paper is Geographic Knowledge, or ICT, right? And in particular, we see that there are a lot of internet adoption in our life and also in our work, right? So here I just present some data here. On left panel is some data from WDI. It actually plots internet users per 100 people within the United States. We can see that there is a dramatic increase after 1980s, right? And the right panel is from the current population survey within the US as well. It actually shows that the fraction of people who answer that they actually use internet in their job is actually increasing as well during the past 3 or 4 decades. Okay, so this is the fact. There is large increase in the development in the ICT, especially for internet. And it has been, well believed that this ICT improvement has profound impacts on the labor market through the lens of geographic fragmentation. So when we talk about geographic fragmentation, we can have several meanings. For example, we can think about the sourcing, right? So a firm may contract its part of its manufacturing service to another firm. Right? So that's called sourcing. And also we can think about headquarters subsidiary relations, right? So for example, it's the headquarters may be in the United States, California, but the subsidiaries may be in another place, in another country, or in another place within the US. So that's called geographic fragmentation. And so in the literature, people have started this geographic fragmentation in the context of international sourcing and headquarter subsidiary relationships across countries. Right? So there is a huge literature on this international geographic fragmentation. So I listed several important papers here. However, we think that this phenomenon of geographic fragmentation has not been well started or has been underexplored within the context of a country. For example, we can think about the geographic fragmentation may happen between New York and Texas, right? So it's within the country's border, but across different locations in a country. So we think that there are this geographic fragmentation within a country, which we call domestic fragmentation, is very important in the data. So based on a BCG report, they actually find that 95% of sourcing is actually done within a country, but not like in an international context. And similarly, in Teresa Ford's paper, she also finds that actually most of the sourcing or the geographic fragmentation is done within a country, but across different locations instead of international geographic fragmentation. So what's the key difference? So the key difference is that usually we think that if we talk about international geographic fragmentation, usually we assume there is very little labor mobility across different regions or different countries. Right? But when we think about this question within a country, then the labor mobility will be largely increased. So for example, if we think about a long-run change in the labor market, especially like 3 or 4 decades, we will think about there is a very large labor mobility across different regions, like for example, between New York and Texas. Okay? So our risk question will be that how the rise in these cross-region productions driven by this ICT improvement, or in particular, we studied the internet improvements in our empirical study, shifts this distribution of skills across US cities. Right? So this is not like in the international context, but within a country across different locations. And how will that shift welfare? And because of this labor mobility, the welfare implications may also be different from what we have known from the international geographic fragmentation. Okay? So this is the
Hi, Yang. Can I have a question? So you know this paper by Fabian Eckert, who is looking at the increase in the trade cost of services and how does that affect the allocation of labor across U.S. states or cities, right? So that sounds very much related to what you are talking about. So what's the difference between your story and his?
I think in their paper, they mainly focus on like different sectors and there are trade, right? So within the service sector, but what we focus on here is quite different in the sense that, for example, even within the manufacturing sector, you can think about there are a lot of sourcing. There are headquarter subsidiary relations. And also in their paper is basically a heteroline story, which means that they focus on the different sectors heterogeneity in terms of their skill, the intensity, all this kind of stuff. But in our paper, it's mainly about within sector allocation.
Right. So the other question is, so are you going to focus on the manufacturing or you go focus on more generally? Because manufacturing is, in terms of employment, is a quite small share of the U.S. labor force, and mostly are in services. So services are quite important.
I think we will focus on the more general economy. We think our framework connects not only the manufacturing sector, but also the service sector. For example, for this headquarter and subsidiary, even for restaurants, you can think about maybe you have some recipes in your headquarter, but you can open a lot of subsidiaries.
Good. So you're not just in manufacturing. That's good. Okay.
Yeah, right. Yeah. So we view it's a general thinking about this geographic fragmentation. Okay. So we show some statistics with micro level data from the US. First, we show that in the US, there is a phenomenon called spatial skill segregation, which means that we already know that at a given time, large cities have a higher share of skilled people, right? So, but we also see that during the past 3 or 4 decades, this phenomena has been more pronounced in the sense that the share of the skilled worker in the big cities has been increased even larger than the small cities. Although at the national level there is an increase in the skilled share, but it's more pronounced in the big cities. Okay? So in other sense, that we are focusing on the change in the labor market. So we also relate this empirical finding to the geographic fragmentation. We try to show that industries that tend to fragment, so we will be more clear about what industries tend to fragment. we will see large increase in this spatial skill segregation. Or in other words, we see that in industries that are easier to fragment, you will see larger segregation between the skilled and the unskilled spatially. So motivated by these facts, we will build up a spatial equilibrium model of, with this production fragmentation and also with heterogeneous agents. We will have two types of agents, the high skilled and low skilled. We view the production process combine the knowledge intensive jobs, for example, R&D management. So these are skilled jobs. And it will also combine the standardized production, right? So for example, the assembly process is very standard. And these tasks or jobs are going to be performed by the low skilled or the unskilled. Okay? So because this is a spatial model, people will choose their location, right? So since the production will combine the high skilled and low skilled, and the skilled and unskilled, they will be distributed across different regions. When we see this communications cost declines, then actually the cost of this communication between skilled and unskilled remotely will be declined, right? So essentially it says that if the high skilled and the unskilled, they can communicate in a remote distance, then they do not have to locate in the same place, right? So otherwise, within the production team, they will have to be located in the same region, right? But with this communication cost reduction, they will be able to fragment and will be able to be located in different regions. So this is our basic idea. And we will find some empirical support for our model predictions. In particular, we will try to show that in the US, there will be heterogeneity in the internet improvement across different regions. We will show what's the implication of this internet improvement for different regions and how would that change the skill share in different regions. So we will study this empirically as well. And finally, we will do the quantitative evaluation based on our spatial equilibrium model. The purpose of this quantitative evaluation is to try to see the importance of this internet improvement on accounting for the skill redistribution in the US, and what's the implication of the internet adoption for the welfare for both the high skilled and low skilled.
Yeah, can I ask a quick question? So suppose we assume complementarity between skilled and unskilled, and then so following exactly the same logic, I think in order to support empirical prediction, say you probably need to assume a stronger complementarity between skilled and unskilled, then complementarity among the skilled. So if we allow complementarity among the skilled, then with the decline of communication cost, you may expect to see, following the same logic, you may expect to see decentralization of professional services instead of seeing this concentration of this thing. So do you have any thoughts on that?
So I think that's a very good insight. So in our framework, right, so actually we focus on the communication cost between the remote communication cost between the skilled and unskilled, right? But in reality, it's true that there may also be some remote communication between the high skilled and the low skilled. So I think that could be what happened in reality. So what we think here is that so we focus on the geographic fragmentation of the zone of the internet, but there are for sure other zones of this internet in reality, right? So we can for sure extend our framework to incorporate other dimensions of how internet changes the economy. But in this paper, we specifically focus on how internet changes the economy through the lens of this geographic fragmentation in the sense of this cooperation between the high skilled and low skilled. Does that answer your question? Yeah. So we focus on a specific channel, yeah, but we do not rule out, internet continuous economy in other ways. So I will just directly skip this related literature, and usually readers can just refer to our papers, I think, for the sake of time. So this is the star aspect. For the micro level data, we use this IPMOS data for the US. What we have is that we have a 1980 the census data, which is 5% of the US population. We also have the 2011 to 2013 3-year ACS data. It's the 3% of the US population. And we pick up the individuals between age 16 and 64, which we directly follow the literature. And for the local labor market, we define it as commuting zones, right? So in the US, we know that there are 722 commuting zones following the work of David Alter and his co-author, right? The EDH China shock literature. And for the, we measure the city size as the total labor supply. Total labor supply means that for each worker, you supply some hours of work, right? You just sum up all. Okay, so we will define two skill groups, the high skill and low skilled. The high skilled, so we actually rank all the occupations within the US using 1980s wage information. So that we rank all the occupation in the US, and we define threshold like 75% of the threshold, so that for the top 25%, we think that's the high skilled jobs, and the lower 75% is the low skilled jobs. But we also try the other threshold, like 80% and 67%, our results are robust. And also for the skill definition, we also try the education, high skill defined as people who has a college education, but all our results in the empirical part is robust. So what do we see in the data? So here I plot the relationship between the city size and the skilled share. On the left panel, it shows this dotted line is the 1980s data. And we run just a simple linear regression for different cities, scale share and the city size, right? So we find that there is a positive relationship. And in 2013, there is also a positive relationship. But this slope has been much steeper than the 1980. On the right panel, we directly use the scaled share in 2013 and subtract that by 1980s scaled share and regress that on the city size. We find the same conclusion, right? Basically, there is actually an overall increase in the scaled share within the US in different locations, but this has been more pronounced for the big cities rather than the small cities. We also directly run these regressions and try to control for the state fixed effects. And we find that this concluded that in the US during the past several decades, there has been a skill relocation to the big cities is actually robust. So this is the empirical finding on skill share. And also we use other ways to look at this skill segregation. This is Kramer masking segregation index. Basically, it tries to capture to what extent the high skilled and the low skilled are spatially distributed in different cities. So this ZO is the Kramer masking segregation index. This pi CS is, this S means sector S. Pi CS is the high skilled employment share in sector S and in CTC. And pi S is the skilled share in sector S at the national level. Pi CS is at the city level, right? So if these two are very close, it means that this zone is very near to zero. However, if there is a large dispersion of this pi CS, high skilled share in different locations, this zone will be much larger, right? So basically, a larger zone implies a great extent of segregation across space. We also find that in the data, this Kramer masking index actually almost tripled during the past 3 or 4 decades. And also we try to show some confidence intervals, try to show that this is actually significant change. Okay. So, and finally, our final style aspect is trying to combine this spatial segregation or the skilled relocation with the story of this fragmentation. What we do here is that for each industry, we can calculate a crema masking index, right? Segregation index. So each dot here denotes an industry. Okay? On the x-axis, we put the Forbes 2017 firm sourcing index. So what's this? This is a way to measure to what extent the industry is easier to be fragmented. Okay? So Forbes actually measures for each industry. She computed for each industry what a fraction of plants actually have this sourcing or contracting manufacturing service with another plant. For example, in the computer industry, we see a lot of sourcing, but in the bakery industry, we see very little sourcing. Okay. On the y-axis, we put the change in the sector level crema masking index, segregation index. We see that there is a positive relationship between these two. That is, for industries that are easier to fragment, we actually see a larger change in the spatial segregation of the high-skilled and the unskilled. Right? So this is the way we try to link this spatial segregation to the story of fragmentation as a motivation fact. Okay. Just a quick summary. We present 3 status facts. The first one is already very well known, right? So large cities have a competitive advantage in skill-intensive activities, so that we actually see in the data the skilled share in big cities is larger than the skilled share in the small cities. And dynamically, we also see that this pattern of specialization has become more pronounced, so that we see that the skilled and unskilled workers, they have been more segregated geographically. And finally, we link this this spatial segregation to with the production fragmentation, in the sense that we see that industries with a higher tendency to fragment, actually we see a larger increase in the spatial segregation of the high skilled and low skilled. So then it comes to our central hypothesis. We try to argue that internet technology, ICT improvement can reduce the communication frictions, so that geographic fragmentation becomes more viable. So if big cities they have competitive advantage in high skill intensive activities, then if the fragmentation cost is lower, they will try to locate their unskilled jobs to places with lower wage instead of in the places where the high skill lives in, right? So because now it's easier to fragment to other places. So we show that this will reinforce these initial patterns of specialization, and this will lead to spatial redistribution of skills. And in our quantitative framework, we also do some evaluation of the welfare implications. Okay? So in other words, we will study these questions from the theory point, theoretically, empirically, and quantitatively. So now
Yang, how can you differentiate between communication cost reduction and knowledge exchange productivity?
Sorry.
There's a field talking about knowledge exchange, and the bigger city facilitates more easily knowledge exchange, which you may quote that as reduction in the communication cost or effectiveness of knowledge exchange. So can you identify it?
Yeah, so very good question. So I think when we talk about communication cost, it's between high skilled and low skilled in our framework, right? We think that in this process, it involves a lot of knowledge exchange. For example, the high skilled need to give some knowledge to the unskilled how to produce. And maybe the unskilled need to give some feedbacks to the high skilled, and the high skilled do the problem solving, right? So in this process, there is indeed some knowledge exchange, we think.
Yeah, but the hypothesis would be very different, right? Because knowledge exchange has been found very localized because of a lot of tacit knowledge, right? So like more like personal touch. So the pandemic will kill quite a bit of those, of course, right? So yeah, this is why I raised the question.
Yeah, very good question. Actually, I think that maybe I can answer your questions from 2 dimensions. The first one is that, again, in our paper, we just focus on a specific channel, how internet or the ICT shapes the economy, right? So in other words, that we actually do not exclude that internet can affect the economy in other ways, but we have a focus here. And secondly, for the knowledge exchange between, for example, the knowledge exchange between the high-skilled locally, right? In our theoretical framework, we actually incorporate agglomeration force, which actually is just between the high-skilled. Or you think that the agglomeration force between the high-skilled is stronger between the high-skilled, and this follows the tradition of Davis and Bingo's work, right? So they try to argue that there is this personal face-to-face talk, it will facilitate the knowledge exchange. So that's our way to do it. Yeah. And also in our quantitative work, we will calibrate the agglomeration force and we also try to see that how important it is. Okay. So let me go to the theory. The theory part is that there are a finite number of cities. For example, there are n cities, right? So and each city there is exogenous housing supply, HN. So we will relax this in our extensions as well, so that we have elastic housing. But for now, we just assume there is a fixed.
Sorry, Yang. There's a question from Laura Wu. Laura, do you want to speak up now?
Yes.
Okay, so if Laura cannot speak because of the technical setup, Laura's question is ICT assumed to be exogenous?
So in our framework, it's assumed to be exogenous, yes. So it will work as iceberg cost, similar to the trade cost. The communication cost will also work as iceberg cost, and it's exogenous in our framework. We'll see later. But in our empirical studies later, we will discuss the possible endogeneity in the ICT. So, and we try to address that endogeneity. But in the theory, it's exogenous. Okay. So we assume that in the economy, there are 2 types of label. One is the skill label. It's given by LM. This M means managers. Okay. So these are high skill, M managers. And there is also a fixed supply at the national level for the unskilled labor. They are called production workers. So they are LP. P means production workers. 2 types of workers. And the agents inelastically supply their labor, and they are fully mobile across locations. That's our assumption. So because we look at the changes through 3 decades or 4 decades, right? So we look at the change for a long time. So we assume full mobility for this high skill and low skill in our framework. And the utility function of these 2 types of labor is very simple. They will combine a homogeneous skilled X and also the housing. So and it's called Douglas form. So alpha share of their expenditure is on the homogeneous skilled, and 1 minus alpha is on housing. So this is the production in the economy. So what's the production? The production actually follows the tradition of Lucas 78, the standard control model. So that it combines the 1 manager and many production workers, right? So the manager will decide the size of the production team here. So why NC? So this N means the location where the managers live, and this C means the location the workers live. So there is a productivity term here, ANC. Okay? So this is the productivity of the production team. And LC is the number of production workers this manager who lives in N will hire. Okay, so we will choose this LC, and this better measures the span of control. ANC is manager's productivity here. It will be related to the following terms. The first one is the agglomeration force, which we assume that if a manager lives in a city where there are a lot of other managers live, right? So this LNL means the number of managers, M means managers living in city N, right? So they will benefit from that. This is the knowledge exchange which Professor Wang just kindly mentioned. Another term is the ANC bar here. ANC bar is going to be a random draw. So it's going to be a random free-sheet job. So this actually adopts some technology from the trade literature, right? So it's a free-sheet job. So that for any manager living in a city N, they will try to find the places with the high productivity, right? And they also will try to weigh other factors which I will introduce later. So this ANC bar is a free-sheet distribution. So, and Tn is the technology parameter for CTN, and this theta measures dispersion of managers' productivities. Okay. So this is a free-sheet job. So given this productivity ANC, we can just write down the income of a manager living in CTN when they hire workers in a given city, CTC. Right? So basically, they get the revenue and they pay the labor cost. Notice there is a tau NC here. This is actually the fragmentation cost or the communication cost that we mentioned. Okay. So, and this tau NC is the fragmentation cost or the cross-city communication cost, right? So it basically will be affected by ICT in our framework. So we will assume that we will normalize the tau N equals 1, right? And the tau NC is larger than 1. So that when you do a remote cooperation between the high skilled and low skilled, you will suffer from some iceberg cost. And so that we can, with this in mind, we get the income of manager living in CTN, and they decide if they decide to hire workers in CTC, right? So what do we have? This WC is the wage in CTC, right? So the income of manager living in CTN, their profit from hiring workers in CTC is going to be affected by the iceberg cost, will be affected by the wage cost, will be affected by the productivity, right? So you can see that higher productivity, higher profit of the manager, higher iceberg cost, lower profit, and a higher wage cost, and the lower of the profit for the managers. And remember, we have the free-sheet productivity assumption so that we can get a fragmentation gravity equation with some algebra. So what do we find? We find the probability that a manager living in city N, they decide to locate their production teams in CTC is going to be related to the iceberg cost, tau NC, and also the wage, right? So higher wage in the city, the manager lives in, will discourage the manager to hire workers there. Okay. So for example, if a manager lives in New York and the labor cost there is very high, then that will discourage this manager to hire workers there. However, if this tau NC, this cross-city iceberg cost is very large, then the manager will also be discouraged to hire workers in that places, right? So that you can imagine that if the communication cost between New York and, for example, Alabama is very high, right? So although the labor cost in Alabama is very low, the managers may not want to locate their production teams there. So this is the basic idea.
So I have a question. So here, the fragmentation still happens within the firm, right? So it seems that in your formulation, that the manager is in the headquarters and decide where the production is going to happen, right? So then it would imply that over time, as the communication cost goes down, the wage inequality will be within firm rather than between firm. But we know empirically, most of the rising wage inequality is between firm, not within firm.
So very good
so seems that maybe in order to reconcile that, you want some real outsourcing, not I mean, also the measure of outsourcing is not necessarily within firm, it's cross firms, right? Cross firm boundaries. So there seems some the disconnect between your model and the outsourcing. You need to take the outsourcing seriously. So
thank
you
you.
really buying the labor services from other cities rather than having a partition unit in another city.
So thank you, a very good question. So actually in our framework, we do not take a stand whether this cooperation between the high-skilled and the low-skilled happens between firm or across firm, within firm or across firms. So for example, you can think about some firms may, so when we talk about this geographic fragmentation here, the cooperation between the high-skilled and low-skilled, it can also happen between different plants or different firms, right, in different cities. So like a sourcing, right? So we do not specifically say that this framework just applies to within firm. We think that this framework can be interpreted as the cross-firm cooperation as well.
Right. So in that case, then yeah, I mean, the way you formulated the boundary of firm is not very clear. It's, but I guess when you want to take to the data, that's going to be important.
Yeah, very good question. I think maybe I didn't explain it clearly. So here we do not take a stand. We actually do not take a stand whether it's within firm or across firm at all. But when we go to the empirical part, we will talk more about your question. So from this fragmentation gravity equation, we can actually calculate the expected income managed, which is the following form. It basically is going to be related to the agglomeration force and also the technology in a city. So I will quickly skip this. So the spatial equilibrium is pinned down by the spatial indifference conditions. The high scale and the low scale, they will be indifferent in living in different locations. So if you look at the production workers, they get the wage in different cities, like N and N prime, right? So two cities. But they will also consider the living cost. This Pn to the power of 1 minus alpha is basically the price index. And this Pn is the housing price. So that they will weigh the wage and also the living cost. And that's similar for the managers. For the managers, they will also calculate their expected income when they decide to live in a city, and also the housing price in a city. So that's the spatial indifference conditions. So now let's talk about some equilibrium properties from this simple model, right? So what we show here is that when we have infinite fragmentation cost, in other words, all the cooperation between the high scale and low scale is within a city instead of across cities, right? And we take some simple functional form for the agglomeration force and impose some regularity conditions so that the spatial equilibrium exists and is unique. What do we find? We find that actually cities with bigger technology parameter Tn, they have more of this high scale and also more of the low scale. So this is in the case of infinite fragmentation cost. And in this case, we also derive the scaled shear in different cities. We find that this scaled shear is actually the same across all cities when this fragmentation cost is the same. Because in this case, big cities, they will attract both more of the high scaled and also more of the low scaled, and they are proportional to each other. Because in different production team, in these production teams, the number of managers and the number of workers will be proportional. So that's why the scale shear is not going to be changed with the city size. However, when we consider the case with this internet openness, or when cities can do this fragmentation, i.e. the communication cost across regions is not infinity, then what do we find? We find that actually when there is a more connection between the big cities and the small cities, the big cities will attract more of the high skilled, and the small cities will attract more of the low skilled. So that we see there is a change in the share of the high skilled in the big city, and also the change in the share of the managers are skilled in the small city. What's the direction? We find that when the communication cost reduce or the ICT openness increases, the high skilled share in big cities will increase, and the high skilled share in small cities will decrease. The basic intuition is also what we have mentioned, that the high scale and low scale, now they can be located in different places. they do not have to be located in the same places. So the high-skilled managers living in the big cities, now they can, just locate their production teams to in small cities by leveraging the lower labor cost there, right? So that's the intuition. And we also find that when you have a higher agglomeration force for the high-skilled, this phenomenon will also be more pronounced. So in any case, our theory will predict if there is a local internet improvement for the large cities, there will be an increase in the high-skilled share. But for small cities, there will be a decrease in the skilled share. Right? So,
sorry, Yang, I have one more question. So what do you think is the difference, the source of the difference of T, of capital T?
Sorry,
What do you think is the source of the difference in capital T that give rise to the large and small cities? So you assume there are some exogenous distribution of T, right? So if I think about T itself is endogenous, let's say part of your first agglomeration sources, then wouldn't that lead to some multiple equilibriums?
Very good question. So firstly, for TN, we think that it can come from, for example, the city has, it can relate to many things like policies, like different fundamentals. For example, some cities, they have some endowment that's easier to do some kind of, industries. And also it can be related to policies. For example, the tax policy in different cities may also differ, right? And in terms of agglomeration forces, so here we actually have different notations for the technology and agglomeration forces. So for agglomeration forces, we have a separate functional form here, and the technology parameter is exogenous given in the paper. Okay.
Right.
So
I guess what do you think about the source of the difference in T will matter in terms of when you think about welfare? If you think about taxes, then the welfare analysis will be quite different, right? And if it's due to the agglomeration, and then that which means you effectively have the same T, then you have a different equilibrium. So somehow you need to take a stand on that, especially when you do the welfare analysis.
Yeah, very good point. Actually, so for the agglomeration forces, I think it's, so we know that actually when you have higher agglomeration forces, it's possible that there may be multiple equilibrium, or sometimes maybe some cities just agglomerate all the skilled workers, right? And some cities do not get any skilled workers. And we derive some regularity conditions here in a special case. But for the general case, we are not able to derive these regularity conditions. However, in our quantitative evaluation, we actually try to solve our model, and we use iterative method. We find that the equilibrium, no matter where we start from for our numerical exercise, no matter where we start for the initial value of the algorithm, actually it converges to the same solution, right? But theoretically, admittedly, we do not have a proposition for what is actually the conditions so that there aren't, multiple equilibrium. That's a good point. So these are empirical setting. So what do we do? So the left-hand side is the high-skilled share change between 1980 and the 2013. On the right-hand side, what do we put? We put the change in the internet quality for different location I, right? And we also interact this internet quality change for different location with this city size. Our theory basically says that for big cities, when there is an internet improvement, high-skilled share will increase. But for small cities, when you have internet improvement, the skilled share will decrease. So when we have this interaction term, what do we expect? We expect this beta 2 is smaller than 0, but this beta 3 is larger than 0. Okay? So that for big cities, internet quality increase will drive increase in skilled share, but for small cities, it's the opposite. So we do some empirical support. So due to the time constraint, I will quickly skip this. So data source is from US FCC on the internet quality. Basically, it's about different internet suppliers. They will report their bandwidth to the FCC so that we are able to construct this city level, communication zone level internet quality. And for this empirical setting, it will face some challenges. The first one is that when we do this exercise between 1980 to 2013, firstly, we need to consider whether there are long-run local employment trends, right? And we also, this empirical setting may also suffer from omitted variable bias. And also there may be some reverse causality arguments for our empirical setting. So what do? Basically, for this omitted variable bias, it has to satisfy the following. The omitted variable has to drive the scale share, has to increase the scale share in big cities and increase the internet quality there, right? But for small cities, this omitted variable has to decrease the scale share and increase the internet. We think that it's not easy to come up with such stories. However, in order to fully solve to solve the concern to a large extent, we will also use the identification strategy that will employ some instruments. So the instrument we use here is that we will employ the average elevation of the local terrain of different locations. So in the literature, people have used this elevation of different locations, and they try to argue that if you have a low elevation, it's very prone to flooding and summer temperature, which will make the installation and maintenance of the internet infrastructure harder. So that in these places, you would expect the internet quality is lower, controlling every other factors. And for the long trend argument, we will try to do a placebo test using the information of the high-skilled employment share between 1950 to 1980. So this is our results. The first column is the OLS without state fixed effect. We confirm our series prediction that when a large city they have an internet quality increase, you will see a high-skilled increase. But for the small city, when you see internet quality increase, you will see a scale share decrease. And in the second column, we control for state fixed effect, and we find our results are robust. In the third column, we will use our instrumental variable approach, and we find that these point estimates are actually even larger, and it confirms our prediction as well. And for the long trend concern, we actually tried this between 1950 to 1980. We find that actually there is no such trend between this period. And remember, between 1950 to 1980, there's no internet yet, right? So there's no use of this internet especially in jobs, right? So we do not find anything here. And another concern of this empirical strategy is for this exclusion restriction. The internet quality in our theory, it will affect the production fragmentation, and then it will affect the scale relocation. But how do we know that there is a mechanism like this is working, right? So we only show that internet can affect the scale relocation. What we do is that we will try to just assign different locations by using their industry composition information. So we will separate cities into two groups based on the average fragmentation index, fragmentation intensities. How do we do that? So because we know the first sourcing index, right? And we also know the employment in each industry in each location, so that we can calculate this average fragmentation intensity in different cities. We would expect our story will only work for those cities with industries that have a larger tendency to fragment, but not in other cities, right? So we actually confirm that's the case, right? So this ICT relationship between ICT and scale share mainly happens between within the fragment intensive cities, but not in the non-fragment intensive cities. So this is our way to deal with the concerns on the exclusion restriction. So No more question. I will go to the quantitative analysis. So for the quantitative analysis, we can extend to various extensions of our model to incorporate many mechanisms that may be at work and may potentially affect the scale relocation. Right? So here we do a simple extension, which is the elastic halving supply. So that elasticity of halving supply is mu. Right? But we can potentially do other extensions like endogenous amenity, which is very important and pointed out by Diamond 2016. And also some scale-based technical change, all these kind of other stories that ICT may also impact the economy, right? So, but for now, we just do this one extension with elastic halving supply. When this mu is 0, we go back to the special case that there is inelastic halving supply. So for the parameter values, we will do the following. So firstly, we will assign some parameter values from the literature, like the shear spending on the halving, the span control, halving supply elasticity. But for other parameters, we will try to match the data. So firstly, for the strength of agglomeration, we will try to match the elasticity of wage. Production workers' wage are different across different cities, right? So we will match the elasticity of wage with respect to city size. And for the dispersion of manager productivity theta, and since we have the managers, income distribution derived from the model, and it's going to be related to the parameter theta, we will try to estimate the theta using the data of this manager or high-skilled hourly wage distribution. And for the housing supply, actually bar, we will match the city size wage and their total income. For the city technology, we will also match the level of wages, the city size, and the fragmentation potential of parameters. Okay? So these are some parameters which are relatively traditional, but there are some new things here, which is about the fragmentation cost that we introduced in the paper, right? So we will assume that the fragmentation cost, tau NC, when we take a log, it's going to be related to the following terms. It's going to be related to the distance, bilateral physical distance. It's also going to be related to the internet quality we introduced previously in the empirical part. Right? So we assume that this internet quality of city N and city C, they actually enter in the following way. QNC equals QN multiplied by this QC. We adopt this functional form trying to capture the following idea. That's one, so this is actually a complementarity term, right? So basically we try to think about this, how internet affects the communication cost, like if a city N or C, either city N or city C has a very low internet quality, then it's going to be very difficult to communicate, right? So one side will affect the overall a lot, right? So that's the functional form we take. And we know this QN and QC data as well from the FCC. And also we introduce other bilateral costs like language barrier, race difference across regions, and whether they are in the same state, these kind of controls. But how can we get this? We can directly get this QNC and DNC from data, right? But how can we get this tau NC, the bilateral communication cost or the fragmentation cost? So we will employ our fragmentation gravity equation, right? So in our fragmentation gravity equation, we basically say that for a manager living in city N, they have some probability of locating their production team in a given city C with some probability, right? And if we take in ratios with respect to the city where the manager lives in, i.e. XNN divided by XNN, we will get the following stuff. The following thing is going to be related to the labor cost and also the bilateral pairs. This XNC is the bilateral pairs of these production teams, right? The high-skilled and low-skilled corporations. And now it becomes a question. W wage information is already in the data, but how can we get these bilateral corporations? And I think this goes back to Professor Zhu's good point that actually here, when we measure in our quantitative work, when we measure this X and C, we actually use the headquarters subsidiaries information from Orbis database. We think that this is only one way of geographic fragmentation. It's not all the form of geographic fragmentation. But we do not have data on the sourcing. For example, a firm actually source part of its tasks to another firm, right? So this is the data limitation we actually use here. We think that this headquarters and subsidiary is one firm, right? It's one representation, but it's not all the firms. So this is one caveat here. In any case, we will use this data set to try to calibrate this coherency. And after we get this coherency, we can run this type of gravity equation, right, with information of the bilateral distance and also the bilateral internet connectivity. What do we find? If we run our OS regression, we find that the bilateral distance will increase the fragmentation cost, but internet connectivity will decrease the fragmentation cost. And this result is robust when we do PPML, right? So because there are many zeros in the data actually. So this is the way to get this delta D and delta I, i.e. in what ways this physical distance and internet connectivity affect the fragmentation cost. And with these parameters in mind, we are going to be able to do some counterfactual exercises. So what's the exercise? So what we do is that we will take the 2013 as the benchmark. Okay, so in the benchmark, we already have the internet quality data, right? So we have the fragmentation data as well, right? So with these parameters, we can solve the equilibrium and get different cities scaled share, right? And in that case, so it's called with internet, because in 2013 we have internet when people do their jobs. And we can try to plot this relationship between scaled share and city size. This is a regression, okay? Regression results. And for the no internet case, how do we perform this exercise? For the no internet exercise, basically we go back to this gravity equation, right? So we will just make this Q1 and QC equal 0. And we get a new tau NC fragmentation cost in the case without fragmentation, without internet, right? In the case of the fragmentation without internet, we can also solve the equilibrium and try to calculate the scale share in different cities and run a simple regression here. And we can also run a regression and compare these two lines. And if we compare these two lines, what do we find? We find that in the case with internet, the slope is larger than the slope the case without internet. And we also do the similar empirical setting as we do in the slides fact, i.e. we just use the scaled share in the case with internet and subtract that scaled share with the scaled share in 1980 without the internet, right? And regress that change in the scaled share on the city size in 1980. And we get this regression line. It's also positive, right, as expected. And what's the slope? The slope from this regression is 0.0031. And we compare this slope with what we do in our slides fact, which is 0.005. Basically, it means that without internet, the observed scale redistribution in the US would have been reduced by about 60%. We also perform some welfare analysis. We find that actually with internet, it will increase the welfare for both the scaled and the high scaled at almost the similar magnitude. Notice this is very different from the international geographic fragmentation, right? Which usually benefit the high scaled rather than the unscaled. And this is because the unscaled now in our framework can be very mobile, right? So they can be located to the places where they think it's very valuable as well. So that they also benefit. And we also decompose these welfare effects into the direct effect and GE effect. What's the direct effect? Notice in our framework, the INSEAD cost actually enters the production function, right? It's effectively a productivity increase or TIP increase for the economy. So that in that case, it will, even if there is no spatial reorganization within each production team, these managers and workers will benefit from this increase in the effective productivity increase, right? So that's the direct effect. And the other part is the G effect, and the other remaining part, which is from the spatial reorganization. So we see that the major welfare effect is from the direct effect, but the part from the G effect is also not negligible.
Yang, sorry, I need to interrupt you. Your time is up. Can you sum up?
Yeah. So this is the last slide.
Okay.
So lastly, we also do some policy experiments. So we know that in reality, there are in different countries and also in international organizations, there are many programs trying to improve internet quality in less connected places. Like even in the US, there is this Connect America Fund, right? Trying to raise the internet quality in small places. We try to policy experiment which will raise the internet quality in cities which is below the median level in 2014 and increase that to the median level and see what will happen. We find that with this more uniform internet improvements, there will be more spatial skill of relocation, and there will also be some welfare increase for both the skilled and unskilled. So I think I will just stop here. Thank you.
Thanks very much. So panelists and attendees, if you have a question, you can stay on and communicate with Yang. Thanks very much. And we will come back at 9:45 for the second talk.
Yang, can I ask a question?
Yeah.
So I think my question is similar, related to what Xiaodong asked, right? So Fabian Eckert has this, he's trying, I thought in terms of motivating facts, the first two of your three facts are kind of also his motivating facts, and more spatial, more scale differentiation across city. Larger cities like New York now has a higher skill share. But his story is also about communication, is the some kind of cost reduction, right? But the idea was, the high skilled now can, say accountants in New York, high skilled accountants in New York can now service, long distance, the demands of meet the demands of in another city, right? For the high skilled services. And before the reduction in the communication cost, this the New York accountants couldn't do, provide the good accounting services for Kentucky or something. So I guess the question is how do you differentiate these two stories? Yours is focusing on the production side somehow. I think Xiaodong's point about you referring to this as outsourcing. It's really like the subsidiary location kind of within firm. As far as I can see, the model is about within firm kind of location decisions, subsidiary location decisions. How do you tell your story from his story that is based on more like the demand side rather than the production side?
Yeah. So very good. So I think firstly, so in his paper, if I understand his paper correctly, right? So his paper is a Hatch-Olin mechanism. Hatch-Olin mechanism in the sense that you think about in different locations, right? So you actually have, for example, two industries, right? Service sector and the manufacturing sector. And for instance, the service sector is more high skill intensive, right? And what he focuses on is that when there is a trade cost reduction, right, in the service sector, for instance, right, then the reward to the high skills in big cities will be larger, right? So that there is this skill relocation. This is actually Hatch-Olin force, right? So trade cost leads to the skill premium in big cities increase, and then you have more of the high skill in the big cities. Okay. So in our paper, it's not a Hatch-Olin forces. It's so It's
Right.
geographic.
I mean, yeah. The forces I understand are different. I'm saying in terms of quantitative implications, that that are used to explain the three motivating facts. For example, is there a way to use his forces, right? The Hatcher Olin forces to explain also your fact number three within sector spatial segregation or something?
I think it's not easy in the following sense. So here, if I show you this Ford 2017 sourcing index, right? Like the relationship between the fragmentation tendency and the change in the spatial segregation of the high scale and low scale, right? Actually, this Ford index is only for the manufacturing sector. It's only available for the manufacturing sector. So we actually find that even within the manufacturing sector, you also observe this spatial segregation, right? So this is not, like in the service sector. So not only in the service sector, right? So even within the manufacturing sector, like a computer industry, right? You compare that with the bakery industry. And for the computer industry, it's very easy to fragment. And you see a lot of this spatial segregation of the high scale and low scales across places. And for the bakery industry, you see very little. And this is just for manufacturing because of the data availability, right? It's not for service. Yeah. But if we have a measure,
maybe one way you can kind of look at this is looking at the prices, right? You should look. You didn't talk about that at all, about the skill premium. So if you want to sort about the supply and demand, that seems that the first thing you should look at is what happens to skill premium. Do you have the right prediction about skill premium?
Yeah, thank you, Professor. I think that's a very good question. In our quantitative work, we actually find that there are, so because we focus on a specific channel, how internet shapes the economy through the geographic fragmentation, right? So what do we find through this channel? We find that both the skilled and unskilled, we see increase in the welfare. And
right, but this is aggregate. You want to look at the skill premium by city size, right? So you want to see whether that the change of that relationship is consistent with the data. So that's where he's focusing on. He's focusing on that part, and he's trying to account for that prices, right? So you should see what by using this channel, can you account for the difference in skill premiums?
Very good question. Actually, in our framework, because we actually assume full labor mobility for the unskilled and the high skilled, right? So that all the high skilled and all the unskilled expectation within each skill group, their welfare is the same. So we only have, so in the current framework, we only have implications for the welfare at the national level, but not at the local level. So we do not have, so in the current, yeah, but if we incorporate, for example, migration costs, that may accommodate like the local change in the skills premium. But for the current framework, we actually cannot see anything on
right,
that.
Right.
That's a very good point. Yeah.
So yeah, one more thing. Will you be able to? I mean, the way you your model allows the communication cost to affect, the high skill and the low skill, the span of control thing versus the agglomeration effect. Right? So somehow the high skilled have to be, in the same city in order to enjoy the agglomeration effects. But high skill can communicate now with the low skill workers in another city much easier. The iceberg cost is now lower, right? So imagine that I would have thought that the internet can also allow high skilled in different cities to. It's a bit before the internet is available. High skill can only really benefit from in-person communications with other high skills. But now you can potentially also Zoom with others in Europe, in China, and so on, right? So if you also bring in this, allow the internet to, in terms of high skill agglomeration, to have this countervailing force, right? On the one hand, they still wanted to be together, but on the other hand, the communication cost reduction somehow will make them more dispersed. Will things be robust to that kind of generalization? It's a generalization of the model. There's nothing. Yeah.
Sorry, Hamin, I need to interrupt in the discussion.
Yeah, we can
So,
continue.
let Xiaodong start the second presentation.